Welcome back, everybody. In this video, we're going to be working on some examples involving simplifying fractions. So let's get started. So the first one, we want to simplify 10/42. So as we saw last time, the way that we want to proceed is by finding the prime factorization of each of the numerator and denominator. 10 is 2 times 5, and 42 is 7 times 6, and 6 is itself 2 times 3. So then writing out the prime factorization for each of the numerator and denominator, 10 is 2 times 5, and then the denominator, 2 times 3 times 6. Okay, or rather 7, 2 times 3 times 7. Okay, so now we can see that there's a common factor of 2 that can be divided out. 2 divided by 2 is 1, 2 divided by 2 is 1. And so what's left in the numerator is simply 5 divided by 7 is 21, 5/21. So here in doing this, it may have occurred to you, well, I saw that 10 and 42 were even in the first place. Could I just divide by 2? And the answer there is yes. Typically, we recommend going through the whole prime factorization process, especially if you were just starting out. But if you are comfortable with looking at 10/42 and just kind of simplifying it straight away, you're welcome to do that. Here's how the work would look if you do that. So I would look at 10/42 and I'd say, okay, well, 10 and 42 are both even. I'm going to divide by 2 on the top and bottom. So 10 divided by 2 is 5. 42 divided by 2 is 21. And so we're right away left with 5/21. Okay, you have to be careful doing that because, of course, you're showing less work. And when you show less work, it's easier to make mistakes. One of the common mistakes people will make is instead of writing down the answer to the division, they'll write down what they divided by. So rather than writing down a 5 up here in the numerator, they may have written a 2. So you want to be especially careful if you proceed like that. Okay, I may show a few examples where we do this kind of shorter version. All right, we'll do one more at least by forming the prime factorization. So let's take a look at 9/27. 9/27, 9 is 3 times 3. 27 is 9 times 3, and then 9 is 3 times 3. So that will be 3 times 3, and 3 times 3 times 3. All right, so now the numerator and denominator each have 2 factors of 3, which we can divide out. We'll divide the numerator and denominator by 3, and then we're going to do it again. So all that's left in the numerator is a 1, and then in the denominator is a 3. So that is 1/3. Again, if you looked at 9/27 and said, well, isn't 9/27? Well, 9 times 3 is 27, so couldn't I just do this? Okay, instead of going all the way to prime factorization, I know 9 divides into 27, so 9 divided by 9 is 1, 9 divided by 9 is 1, and so then this gives us 1/3. Yes, you can. If you're comfortable with it, there's absolutely nothing wrong with doing that mathematically. It's just fine. Okay, usually arithmetic teachers will have you at least begin with the prime factorization because it's less error prone. Okay, so let's try 8/36. This time we're going to just see if we can spot any factors of both 8 and 36. I can see that both 8 and 36 are divisible by 2. So I'm going to divide 8 by 2, and I'm going to divide 36 by 2. Okay, 8 divided by 2 is 4. 36 divided by 2 is 18. I've divided the top and bottom by the same number, so I have an equivalent fraction. That's important. And then now we have 4/18. You'll notice that those are both even, so we can divide out another factor of 2. And you may have seen in the first place that this 8 and 36 were divisible by 4. I just wanted to show one where you did a couple of steps. If you don't see right away that 8 and 36 are divisible by 4, that's fine. You can do it kind of little by little as I have done here. 4 divided by 2 is 2, and then 18 divided by 2 is 9. 2 and 9 don't have any common factors anymore, and so we're all done. Okay, we have 6 more to do, so let's take a look at each of these. So on these, pause the video, or at least for D, E, and F, pause the video, try each of these 3, and then we're going to see how they come out. All right, so I started with the negative 18 over 10, and this time I just did a little bit of factoring. I didn't find the prime factorization because 9, of course, is not a prime number, but I didn't bother factoring it because I know that 3 isn't a factor of 10. So why would I break down 9 any further than I already did? I do know they have that common factor of 2, though, so let's go ahead and remove that using the fundamental property of fractions. This will give us negative 9 in the numerator and then 5 in the denominator. Okay, 12 and 2. I know that 12 is 6 times 2, and 2 is, of course, just 2. And then we can divide out that common factor of 2, which leaves us only 6. Just 6, not even looking like a fraction. And if you look at it, 12 divided by 2 is something you knew long before you knew about fractions. 12 divided by 2 is 6. We just looked at it kind of from a fraction point of view. All right, 21/60ths. I can think of 21 and 60 as both being divisible by 3. 21 is 3 times 7, and then 60 is 3 times 20. So again, here you could make the prime factorization of 60 if you like, but to me, there's no use. You're working yourself harder than you need to by factoring the 20, because what does 20 have as factors? Just 2's and a 5, right? And none of those are factors of 21, so it's a waste of time to do this. All right, we can remove, however, the common factor of 3. 3 divided by 3 is 1. 3 divided by 3 is 1. That will leave us 1 times 7 and 1 times 20, or 7/20. Okay, so we are getting there. All right, 72 and 100. So these numbers are a little bit bigger. That's okay. I can see that 72 and 100 are divisible by 2. And you think of some number bigger than 2 that will divide into both 72 and 100. Okay, hopefully 4. You realize 4 will divide into both, but if you didn't, that's okay. I'm going to do it as if we didn't see that, just because. So 72 is 2 times 36, and then 100 is 2 times 50. So we can divide out that factor of 2 in both the numerator and denominator. That will leave us 36/50. And then again, here you can see that both 36 and 50 are divisible by 2. So 36 is 2 times 18, and 50 is 2 times 25. And once again, we're dividing out that factor of 2 in both the numerator and denominator. That leaves us with 18/25. And that's finished because 18 just has 2's, 2 and 3's as factors, and 25 just has 5's as factors. So there's nothing else to be had here. All right, going on to H, we have negative 150 over 24. So just for fun, let me go back to the prime factorization way of doing this. So 150 is 15 times 10. 15 is 3 times 5. 10 is 2 times 5. And then 24 is 8 times 3, and 8 is 2 times 4. 4 is 2 times 2. Okay, so let me put this back together. Don't forget the negative sign. Negative, and then we had 2, 3, 5, and 5. And then for 24, there were 3 2's and a 3. 2, 2, 2, and 3. Okay, and if you want to double check your factoring, remember that you can always multiply it back together. 2 times 3 is 6, times 5 is 30, times 5 is 150. And then 2 times 2 times 2 is 8, times 3 is 24. So it looks like my factorization is all right. Now to simplify, we'll divide out the common factor of 2 2 divided by 2 is 1 in each case. And then there's also a 3. We're going to divide the numerator and denominator by a 3. Okay, so this will leave us negative. And then in the top, we'll have 25. And in the bottom, we will have a 4. And that does it. All right, 84/16. I can see that both 84 and 16 are divisible by 4. So we're going to divide the numerator and denominator by 4. So 84 divided by 4 is going to be 21. And 16 divided by 4 is going to be 4. And that's it. Okay. All right, so we have more examples to do. So there's a whole mess of them right here. So these I took out of our textbook. Let's try these first 4. On this, pause the video and try these and then see how you do for each of these. All right, so let's see how these played out. For number 41, we had 34 divided by negative 86. So I factored 34 as 2 times 17, negative 86 as negative 2 times 43. So here, the 2's divided out, leaving us with negative 17 over 43. For number 42, we had negative 48 over 14. In this case, the numerator and denominator both had a common factor of 2, which we were able to divide out, and that left us with negative 24 over 7. Okay, number 43 was kind of fun and interesting because both the numerator and denominator were negative. So I split negative 72 as negative 2 times 36. And then negative 92 as negative 2 times 46. Then I divided the numerator and denominator both by negative 2, leaving us with 36 over 46. Then I realized that 36 over 46, both of those are even, so we're able to divide out a common factor of 2, leaving us with 18/23. Okay, and then lastly, 27 over negative 75, there's a common factor of 3 that can be removed, leaving us with negative 9/25. So I hope those make sense to you. If not, let me know and I can help you out with them. All right, moving on, we have 4 more. Okay, so once again, pause the video, try these, and then we will go through them together. All right, so let's check out the next 4 of these. So for negative 92 over 82, there was a common factor of 2 in both the numerator and denominator. So I'm going to divide out that negative 2, or that positive 2 rather, in both numerator and denominator. That leaves us with negative 46 over 41. Okay, in the next one, again, we had both the numerator and denominator negative. I'm going to divide out a common factor of negative 2 from both the numerator and denominator. That will leave us with 22 over 31. Okay, next up, there's a common factor of 3. 3 times negative 7 is negative 21. 3 times 11 is 33. Removing those 3's leaves us with negative 7 over 11. I hope this is getting more comfortable here. 57 over negative 99. 57 is 3 times 19. Negative 99, of course, 3 times negative 33. Again, here I'm not bothering with the prime factorizations. I know 33 is 11 times 3, but splitting up that way is not going to help because there's nothing that will go with that in the numerator. So numerator and denominator, we divide those by the 3's, leaving us just with the negative 19 over 33. All right, so that takes us to the end of this set of examples. We'll have more in just a moment. All right, so the rest of this video is basically just 8 more of these examples. So if you feel like you've got a good handle on it, then you can stop here. If you haven't already. But if you want to continue, of course, obviously, please continue. As before, let's pause the video, try these 4, and then we're going to go through them together. All right, so let's take a look. In 49, again, we have a common factor of 2 that we'll remove. 2 divided by 2 is 1. 2 divided by 2 is 1. This will leave us with negative 11 over 49. If you don't get one of these right, make sure that you know why. If not, let me know and I can help you with that. Okay, negative 33, that will be 3 times negative 11. 69 is 3 times 23. So we're going to divide out that common factor of 3, and that will leave us with negative 11 over 23. Okay, 42 over negative 88. Again, there's a common factor of 2, and we're going to end up with negative 21 over 44. Okay, for negative 100 over 48, there's again a common factor of 4. I divided that out, leaving negative 25 over 12. You'll notice in this one that I just decided to use parentheses for the multiplication. There was no reason for that other than that I just felt like it. Okay, as far as how you do the fractions and simplifying and stuff, it's all the same. You can show multiplication with the dot, you can show multiplication with the parentheses, it doesn't matter. Okay, all right, here's our last 4, and then we're all done. So once again, let's try these and then go through them together. Okay, let's go through these last 4. So here in 53, we have 94 over negative 6. There was a common factor of 2, by which once again, we can divide that out. That will leave us with negative 47 over 3. Okay, in the next one, there's a common factor of negative 2, which we divided out. In each case, we're dividing through, and that leaves by a 1. And so 18/19 for our final answer to number 54. Okay, 55, 10 over negative 86. Again, there's a common factor of 2. Unfortunately for our book, they use common factors of 2 a lot. All right, negative 5 over 43, our final answer. And then lastly, for negative 56, here I just divided the numerator and denominator by negative 1 first, turning it into 100 over 46. And then once again, there's a common factor of 2, which I divided out, leaving 50 over 23. On this one, 55 versus 50, or 54 versus 56. In 54, I divided by negative 2 on both, leaving 18/19. 56, it was just kind of, I just felt like it, dividing out the 2 negatives first and then dealing with the factors of 2 separately. I just felt like it. There was no math reason for doing 54 and 56 differently. Really, it was just, I just felt like it. Okay, so that takes us to the end of our work on simplifying fractions and the fundamental property of fractions. Make sure that you practice this skill because, as I'd mentioned, people mess this up all the way through calculus from time to time. So the sooner you get a handle on this, the better off you will be. And as you'll see sometime later, the ability to simplify and then later on build up fractions is super handy when you're going to be adding fractions later, some other course. So if you have any questions, let me know, and then have a great day.